the water, it's like a continuous cycle. Water is recycling through the environment. This water evaporates from the moist surfaces and then it falls as rain or snow. And of course, water also passes through the living organisms and then it returns back to the ocean. And this we have already seen how does the hydrologic cycle takes place in our previous chapter. Now it's the solar energy, sun's energy, which is basically the driving force for this hydrologic cycle. And how does that happen? With the evaporation, right? When water is hot because of the solar energy, the surface water will evaporate and it will become precipitation like rain or snow or mist. And because water and sunlight are unevenly distributed around the globe, that's why these water resources are considered to be very uneven. Okay, but now what are our water resources? Water resources are like we have the groundwater, we have the aquifers, and we have the glaciers, we have the ice, we have of course, most of the water is found in the ocean. Almost 70% of this globe, our planet Earth, is covered with oceans. So we will see how much percentage each one of them has. Like 2.4% of all water that is fresh. Okay, 90% of it is in the bound form or tied up in like ice caps, in snowfields, or in glaciers. Okay, although most of this ice is located in the Antarctica region and the Greenland, and the floating ice cap is found in the Arctic region and the alpine glaciers. The snowfields supply water to billions of people in those areas, in those regions. Now, climate change is shrinking glaciers and these snowfields pretty much everywhere. In Asia, the Tibetan glaciers that supplies water to major rivers and drinking water for 3 billion people, they are also rapidly shrinking. And there are warnings that these glaciers could completely disappear in the next few decades. And this would definitely bring a lot of suffering and economic losses to the Asian continent. But like I said, that's not alone. We have this overall water shortage. Asia is not the only country. Now, glaciers and snowfield, these are the ones that provide fresh water to many people in those areas in the Arctic, Antarctic. And this is an example picture of the snowpack in the Western Rocky Mountains, and it supplies water, fresh water, to 75% of the the annual flow of the Colorado River. And again, like we said, that because of the changes in our environment, this climate is it is shrinking the glaciers and causing the snow melt to come earlier in the year, and thus it that's how it disrupts the water source, which is very, very important to us. Now, groundwater is one of the sources that stores large resources of fresh water. Or it basically, groundwater originates as precipitation. Okay, so when it rains or it snows, of course, it's mostly rain. Snow is only for a certain period of time in our area, like, the Texas area, if we are the southern area, if we can see, we don't get as much snow as north or northeast, right? So here, if we think about the groundwater, then where does it originate? It of course originates as precipitation, which is your rain, and it percolates, means it goes down in the deeper layer of the soil and rock. And this groundwater makes up the largest compartment for fresh water. The groundwater within 1 kilometer of the surface is more than 100 times the volume of all the freshwater rivers, lakes, and other reservoirs combined. So these are our groundwater zones. So in the groundwater, we will see we have three zones. The top layer is called the zone of aeration. This is where plants grow, and plants and trees and other vegetation grows. It's a shallow layer of soil, and it contains both air and water, and it receives sunlight from the sun. So that's why it is very conducive for the growth of the vegetation. Okay, then right below is the zone of saturation, and this soil layer has pores that are filled with water. So, zone of this zone of saturation is the source of water in most wells. Okay, and then uh, this layer, the top of this zone is called water table, which is the lowest layer. It is the top of the zone of saturation, and it supplies to most of the wells. Now we also know that there are other sources, and these are called aquifers. So these are the aquifers are formed by the geological layers that contain water. Okay, so these aquifers consist of porous layers of sand or gravel, okay, and of cracked and porous rock. Below an aquifer, you will find impermeable layers of rock and clay, which keeps water from seeping out at the bottom. So depending on the geology, it can take from few hours to several years for the water to move few hundred meters through an aquifer. Okay. If the impermeable layers lie above an aquifer, then pressure can develop, okay, within the water bearing layer, as we can see here, okay, in this diagram. Then this pressure in the aquifer will make the well flow freely at the surface, okay. And this free flowing wells and springs, these are called recharge zones. Area where surface water filters into an aquifer, these are called recharge zone. I have highlighted it here. And most aquifers recharge extremely slowly. Road and house construction or water use at the surface can further slow their recharging rate. Okay, and then also contaminants can also filter in. They can enter basically in the aquifers through these recharge zones. You see, it's open zone. All this is the covered zone, but here it is open. So any contaminate like dust, rocks, they can also seep in through here. Now, urban and or agricultural runoff in the recharge zone is often a cause of problem, because um, even I would say urban, like industries and all, their waste can go through these recharge zone. The people who don't have access to clean surface water generally depend on the groundwater for drinking and other uses. River, lakes, and wetlands cycle quickly. So the 16 largest rivers in the world carry half of the surface runoff water on Earth, and a large fraction of that occurs in one single river, the Amazon River, which is, the longest river, and this it carries nearly as much water as the next seven rivers together. Lakes contain 100 times as much water as all rivers and streams combined, but most of this water is in a few of the world's largest lakes. Okay, when we know the Great Lakes, right? Now, what there are wetlands also that contain, that's another source of water. Those wetlands would be like marshes, swamps, wet meadows, and they play a vital and often unappreciated role in the hydrologic cycle. So these marshes and bogs, they have like standing water in there. So I don't know if you guys had a chance, but I had a chance last year to visit these swamps and bogs in the New Orleans region. So you have Mississippi River over here, over there, and then near New Orleans, you would see. I have one of these videos in my YouTube channel. If you want to see those swamps and all, you can check out that video. So the atmosphere is one of the smallest compartments, and it contains only 0.001% of the total water supply. So which is very, very insignificant, 0.001. But it is but atmosphere is an important uh, mechanism. It plays an important role for the redistribution of the water around the globe. Okay, an individual water molecule can reside in the atmosphere for about 10 days. Okay, and some water will evaporate and fall within hours, but water can also travel halfway around the world before it falls. Isn't that amazing? Yeah. And when it falls, it replenishes the streams, the lakes, or the aquifers on the land. Now, how much water do we use? That's a good question to know. We know that water is a renewable source, okay, but this renewal takes time, like sometimes years, right? The rate at which we now use water makes it essential that we protect and conserve our water, especially our local water supplies. Renewable water is most plentiful in the tropical forests where rainfall is heavy and the land masses are large. Mainly, water supplies are resources that are replenished regularly, mainly the surface water and the shallow groundwater. And what are ways, water has always been a key to survival. Here you can see, this is a desert condition, look like a Thar desert, and you see there is all sand over here. It's an arid zone. Nothing pretty much is growing here except for few cacti or very small trees you will see, but pretty much everything is sand here. Okay, and here, um, water is very, very, like I said, for their survival. There is no water body here, right? And they need water. So here you see this animal called camel. It drinks like once in like 7 days or 10 days, and its body is has adapted in such a way that it can store huge amounts of water, inside its body, because it knows when it travels through the desert, it's not going to be able to get any water. So that's how those people, adjust to their surroundings. So we use water for many purposes. As we said, water withdrawal is the total amount of water taken from a water body. Agriculture is our main use I'm sorry, is the main source of water withdrawal. About 70% of the total water withdrawal is used by the agriculture, and this use is increasing, it's not decreasing, right? And if we talk about the meat industry, we will see that uh, if we need a kilogram of grain-fed beef, it takes more than 15,000 liters of water. Whereas if you raise goats on your farm, then that will require 90% less water. So you see, eating beef is costs us much more water as compared to eating the goat, the goat meat, mutton. And same way, if we talk about plants, the rice cultivation, it takes about 3 times as much water as you would grow any other crop like corn or wheat or potatoes, or think about any other. Okay. And so this graph tells us how much, if you see, the most water is the water consuming source is the meat industry. And then we will see this pork, poultry, and rice, soybean, wheat, very less, potatoes, very less, corn, very less. But one interesting thing you can see here, chocolate, it uses, the water usage is much more larger than even the beef industry. You see, this red line is going all the way till like 29,000 of water usage. So what happens is, although chocolate is cocoa and it is a plant product, but to process chocolate we end up using large resources of water. So it costs us more water, way more than even than the beef. Beef is just basically 15,000, but the chocolate industry is using like around 28 to 29,000 of water. So industrial and domestic uses also, are the other ways that we use water. We, for our domestic purposes, we clean our dishes, we wash our clothes, so laundry and dishwashing, washer, and taking showers, and all these things use water. Same goes for the industry. All the industries also need water. So uh, the but the amount of industrial and domestic use is much far lower than the amount of water that is used in the agriculture. Okay. So cooling part water for the power plants is the largest single industrial use of water, and it typically uses 50 to 70% of the industrial withdrawal. So a rapidly growing demand for water is for biofuel production. Okay, it currently takes 4 to 5 liters of water to produce 1 liter of ethanol. So water shortages may limit the may limit a switch to biofuels, because you are just to get 1 liter of ethanol, we are using 4 to 5 liters of water. So if water continues to be in short supply, then it will limit the biofuels production as well. So, like we said, for domestic, we already kind of discussed that we use it for drinking, cooking, washing, everything. And this amount of water basically is different for each household, and depending on how many people live in that house. And poor countries can't afford the infrastructure to obtain and deliver water to citizens. But UN reports that people in the developed countries consume 10 times more water than in the developing countries, because we know that poor countries can't afford so much infrastructure to uh, you know to use the water. Now, how do we deal with the water scarcity? So the biggest problem in water stress and scarcity at a human level occur in Africa as well as in Asia, where rainfall is very low and poor countries cannot adapt to the growing need. The rainfall is low and population is higher in those countries, in those continents. So that's why poor countries cannot build a great infrastructure that can afford them to adapt. So stress, water stress varies geographically, and if we see this area, which are dark brown, like here in Africa, this region, the Western Africa, and the region above India is all this Pakistan, Middle East countries, and China, and Russia. They have very high stress, water stress, like greater than 80%. Now the light brown regions like India, this is India, this is Bangladesh, I believe, yeah, and then this is Australia, and here we have Mexico, and here we have, I guess, one of the South American countries. I believe this is Chile, around the western coast of South America. You see, there the water stress ranges from 40 to 80%. Means these are also very have a lot of very heavy water shortage. Then the areas that are very light and yellow, they are the ones that have less stress. Like that would be the eastern part of the South American continent, and then most of the African countries, they are fine. And the moderately low stress is found in the Canada region, I would say, and moderately high is North America. And that's how you can read this graph chart. So many people lack access to clean water because more than two-thirds of the households have to fetch water from outside the home. This is heavy work done mainly by women and children, and sometimes it takes several hours today. So this we are talking about the developing countries. So this is a like a well, you see, this is a well, and this will be located way further away from their houses, and these women and children have to walk in order to get daily's water supply from this well, which will supply fresh water for their families. So this is what we mean, that this is a heavy work that is done by women and even children. So they will carry this water in these pails, these buckets, and how many of these pails can you basically hold? A person can hold like two pails, so it's not even sufficient for their house, but they still have to go out every day to these rural places and like remote places to get water from their family. That's why they get their children also with them, because children will also be able to hold at least some water, so a little bit water is like more water is a blessing for them. But it's a very hard work. Every day they have to do. Can you imagine walking for water to a very far off place, and just to bring in like two buckets, and sometimes they carry it on their head. One of them they carry on their head, two in their hands, and that's like the most three. That's how the life in some of the rural areas in the developing countries is. The improved public systems bring many benefits to these poor families, but still it's not adequate. So basically, this is we are living in an age of thirst. That's how we can say that a drought, if a drought occurs as an extended period consistently below average precipitation, that has impact on the agriculture, the economies, and overall on the ecosystem. Droughts are often cyclical, and the land uses practices exacerbate their effects. In the United States, the worst drought so far in economic and social terms was in 1930s, when dry years and poor soil conservation resulted into a dust bowl. Okay, so the dust bowl of the 1930s, it only lasted about 6 years, but the mega droughts that destroyed the Anasazi cultures in the 12th and the 13th centuries lasted 25 to 50 years. Can you imagine a drought, lasting for 25 to 50 years? Oh my God. So droughts in the American Southwest aren't a new phenomenon. In fact, the dry spells in the recent years have been relatively short duration compared to the historical events that we just talked about. The groundwater supplies also are being depleted. Although groundwater provides 40% of the fresh water for agriculture and for domestic use in the United States, in many areas of the United States, groundwater is being withdrawn from the aquifers faster than natural recharge can replace it. Okay, so water withdrawal also allows aquifers to collapse, and sinking of the ground surface follows after that. Okay, that's called subsidence. If the aquifer collapse, then the ground will sink, because aquifer is basically like a bowl under the earth's surface, right? So if water is withdrawal from there, there's no water, then the surface will basically collapse and the ground will sink. Another consequence of aquifer depletion is saltwater intrusion. So, a photo taken in 1977 showing subsidence caused by the groundwater pumping in in California's San Joaquin Valley. This is an example. The 1925 sign indicates the ground level in that year, 1977. Okay. So in 1925, this much was the ground level, if you see. And then in 1955, the level became this. But in 1977, you look at this, the groundwater is so low compared to 1925. This sign tells you. So dams and canals are a foundation for civilization because they are the ones that can store water for long periods, and then they can redistribute water for farms and cities. So many great civilizations have been organized around the large scale canal systems. More than half of the world's 227 largest rivers, they have dams. Dams have been built on these large rivers. Okay. So we know in Las Vegas we have this big dam called Hoover Dam. Have you guys had a chance to go there? I have been there. This is a very popular spot. People do go for for tourist purposes also, but obviously the main purpose for this is to store large quantities of water. So that's how dams are built. This is called a Hoover Dam, and it powers the Nevada, the population of the Nevada city in Las Vegas. And this is Lake Mead behind the dam, Lake Mead, and it loses about 1.3 billion meter square per year water to evaporation. Okay, reduced inflows now threaten the viability of this system. And this is a picture where you can see the changes in the Aral Sea. See how in 1973 it was all the water is all available in this Aral Sea, and then 1999 it how much it reduced. And if you look at it in 2015, you see there is hardly any water left. Okay, so um, water will be Fortune magazine wrote that water will be to the 21st century what oil was to the 20th century. This means that in the 20th century they basically were running after oil. They needed oil, right? And people in that era. But right now in the 21st century, we are similar situation, but it's for water, because our water resources are reducing. Okay, so some people say that if not outright warfare, insufficient water, people will basically end up fighting for water. Okay, and like we said that in Kenya, for instance, nomadic tribes have fought over dwindling water and grazing. Underlying cause of the genocide is now occurring in Darfur region of Sudan, where water is very scarce. Okay, so what they do is genocide is like killing the people, because they don't have water scarcity, so people start fighting for whatever resources are available. And when they are fighting, then what are they doing? They are killing also, right? So that's what is means the genocide. There have been at least 37 military confrontations in the past 50 years in which water has been the factor. Okay, so we can now see that how important the water scarcity is. People, it's so important to people that because everybody needs water and they will end up fighting for it and even killing. So changes in precipitation from 2081 to 2000. So we see how this precipitation has become so low over these years, meaning rainfall. So how can, because of all this water scarcity problems, what can we do to conserve water and manage water? So watershed management and conservation, they are economical and environmentally sound ways to prevent flood damage and store water for future for future use than building huge dams and reservoirs. So watershed is considered a more economical and environmental friendly way. Okay. Um, Watershed also is called the catchment area. It is all the land that is drained by a stream or river. It has long been recognized that retaining vegetation and ground cover in a watershed helps hold back rainwater and lessens downstream floods. Everyone can help conserve water. And you remember you had to answer a question in your lab manual when we did the conservation of energy. It's the similar when you for the water conservation. You can take shorter showers. You can fix the leaks. If there is a water leak, we need to really take care of it soon. And using when we use dishwashers, we can try using less dishwasher. And because dishwasher also consumes a lot of water, you can wash dishes by hands, or you can reuse some of the dishes if they're not bad. That's one of the ways. And washing clothes, and everything needs an efficient, you need to build an efficient system that can work for you. And these simple steps can save water, like people take very like even when they are brushing, some people just like to leave the faucet on. That's really not necessary. You can just stop the faucet while you're brushing, and once you're ready to rinse, that's when you can turn on the faucet again and do your work. So we can those were just simple things, but then at a bigger level, we can say we can use water conserving appliances such as low volume shower heads and efficient dishwasher, which can reduce the water consumption greatly. And another important way we can conserve water is that for landscaping purposes, what we can do is that we can plant native vegetation. So, native vegetation doesn't require as much water, especially in regions like dry regions like this Las Vegas, or like even in Texas and Florida. Florida may not be that much, but in California, where you have the drier areas, here you see Las Vegas is paying residents to replace their turf. Can you imagine? It's paying its the home residents uh, to plant these cacti species or palm species instead of planting grass or turf. They are telling them to replace your grass, because grass will or turf requires a lot of water for landscaping. If you don't water, especially during the drier areas, then the grass or the turf tends to dry up. It looks yellow, and then it doesn't look good. Not just for aesthetic purposes, also you can, if you don't have a green grass, then what good is that, right? So they are encouraging in Las Vegas to plant native species. Native species means like in the desert, the native species would be different types of cacti. Sagurao cacti is a big one. So all these people are asked to grow the vegetation that is native to their state. Same thing I can say about Texas. Even in Texas, I've heard they say that plant the Texan trees then that are native to the Texas. So they are naturally well adapted to less water usage, right? So if you have less water, they will still grow and bloom. Makes sense. But if you have turf or grass, then grass will very easily dry away. So another water usage is toilets. We use in the domestic water, the toilet, the dishwashers usage is 1.4%, baths is 1.7%, and others are 2.3. And if we look at this complete chart, you see toilets are the biggest water users, 26.7, which is basically 27% of the total water usage in house. So 27% is used just by the toilets. Then the next 22% is used only by laundry when you run your dryers, your washers. Okay. And then, of course, shower uses the next 17%, and using faucets, people just run their faucets like anything, so that's another 16%. And at the same time, there are some leaks, some a lot of times you'll see people's faucets are not working well, they start leaking, or there is some leakage, outside in the yard area. Some other people don't really take care of that, and they don't even call a plumber or somebody to fix the leakage. So this water leakage can cause the 14% of water loss. Okay, so those little things can go a long way. And what can we do? They are saying don't flush every time you use the toilet, right? Take shorter showers. Put a brick or full water bottle in your toilet tank to reduce the volume of water in each flush. Use water conserving appliances like low flow showers, low flush toilets, and aerated faucets. And gray water could be used for flushing. Do you know what gray water is? Like recycled from other uses, right? Um, like let's say uh, you had some plumbing work done, and they had to open the tap in order to fix your shower, right? So while they are opening the faucet, until they basically turn off the water supply, there will be a lot of water coming out. You can save that water in a bucket. And of course, that water is gray. It's not usable for drinking or showering purposes, right? You can just take that water and use it in your toilet, right? You can flush your toilet with that. Those are some of the ways you can conserve water. So similarly, there are other facts about the conserving the water in many areas. Now, we will talk about the water pollutants. So, what is a pollutant? Any biological, physical, or chemical change in the water quality that affects it adversely, okay, is makes the water unsuitable for desired uses, and it is considered pollution, right? So this pollution, natural sources of water contamination are like poison springs or oil seeps and sedimentation from erosion, right? If the soil erodes, then the sediment settles in, right? And that can spoil our groundwater. Same thing if there is a oil leakage somewhere, and that will seep into the a nearby water body, then that water body gets contaminated. So pollution includes point sources and non-point sources. Point sources the are the ones that discharge pollution from the specific location, like the drain pipes or sewer outfill, such as in factories or power plants and sewage treatment plants or underground coal mines. Non-point sources have no specific location where they discharge into a particular body of water, and they include runoff from the farm fields and the field lots, golf courses. Runoff. Golf courses. They water their turfs and all to keep them look very nice, right? So that when people play golf, they should have a good grass where they can turf to play golf, and lawns and gardens. They also those so there are whenever there is some discharge or leak from those construction sites or other logging areas and all, that those are your non-point sources. Like this is a point source pollution, meaning this is an industrial pipe getting the waste out. You see how colored this water is. It looks so orangish because it could be a chemical industry, or that is releasing their waste, from a abandoned. This could be an acid draining out of the abandoned mines, and so these are considered the point source pollution. So biological pollution would mean when you have some pathogenic source, that is, pathogen was the disease causing source or organism that is polluting the water. Okay, so the most serious water pollutants in terms of human health worldwide are pathogenic. They are the major pollutants, and they can include among these, we have the waterborne diseases like cholera, like dysentery, typhoid, enteritis, polio, hepatitis, and schistosomiasis. So if any coliform bacteria is present in the water sample, coliform means if you have E. coli, you might have heard E. coli recalls, and it was found in like lettuce or in, what you call, a long time back I had heard in spinach. Sometimes what happens is these E. coli bacteria are found there, and they are definitely your biological pollutant, and they are infectious pathogens. They are normally not present, but what happens is, let's say the water supply with which the spinach or the lettuce farm was watered, right, was infected with E. coli, then so that would get into the spinach or the lettuce, whatever that farm is supposed to grow. So now, when we get to eat that, people get food poisoning, and they get sick. So that's called, food poisoning, and it can result in dysentery, diarrhea, and it's a big loss. Diarrhea really is a very what do you say, people can get really dehydrated because of diarrhea, and it can lead to the death of the person, especially in small kids. And other dysentery kind of like Shigella, Salmonella, or Listeria, they can cause serious fatal illnesses. And because these infectious agents are definitely present in our environment, but that's how they creep in our water supply, and they can make the drinking water very, very unsafe. Now, what is biological oxygen demand? This last week we did the lab on the dissolved oxygen. Remember, guys, you use the Winkler's method to calculate the dissolved oxygen levels. So that's what this is about. So oxygen is removed from water by respiration and chemical processes that consume oxygen, because oxygen is so important in water. Dissolved oxygen levels are measured to compare the water quality in different places. Okay, so organic materials such as sewage or paper pulp in water increase oxygen consumption by the decomposers. Okay, in organic material, oxygen is increased by the decomposers, because when they will consume, they will the paper pulp or sewage, whatever they are growing in, they will increase the oxygen consumption. They will consume the oxygen. So biochemical demand is, or BOD, is the amount of the dissolved oxygen that is consumed by these microorganisms that live in the water. That's why they are called aquatic microorganisms. Now, chemical oxygen demand is a measure of all organic matter in the water, whereas BOD is only the biochemical oxygen demand. So, plant nutrients and cultural eutrophication. This is when rivers and lakes that have clear water and have low biological productivity, they are called oligotrophic. Oligo means little, trophic means nutrition. So, they have very little or low biological productivity, and they come under the category called oligotrophic. What is eutrophic? Eu means trophic and well nourished. Okay, that's eutrophic. These eutrophic waters are rich in the organic materials as well as in the organisms. Now, what is cultural eutrophication? Cultural eutrophication is the activity of the humans that increases the eutrophication process. Cultural eutrophication is caused mainly by increased nutrient input into a water body. Increased productivity in an aquatic system can sometimes be beneficial. This is a eutrophic lake, you see. Eutrophication produces the blooms. These are called algal blooms, which are nothing but thick growth of the aquatic plants and algae. And it is stimulated by the elevated levels of nitrogen and phosphorus. Then, after a while, in here, when these algal blooms are there, the bacteria population will also increase, and then bacteria will consume all the oxygen that is there and other nutrients, and then it causes cloudy uh, color of the water, and also there will be bad odor, bad tastes of this water. So nutrients from agriculture and domestic sources, they have stimulated the growth of algae and aquatic plants. This reduces the water quality, and it changes the composition of the water, and it lowers the uh, recreational and the aesthetic value of a lake. So this kind of a lake is called eutrophic lake. You must have seen this kind of a water body around your houses, or wherever you live. You might have seen, or maybe if you visited somewhere, you might have seen these kind of lakes. So, eutrophication can also occur in marine ecosystems, also, meaning partially enclosed seas like Black Sea, Baltic, and Mediterranean Sea. They are kind of not open on all the sides, right? They are partially enclosed, so they tend to be become they are eutrophied. So effluents from the nearby large cities are dumped in the without any treatment into the sea, and the beach pollution, and the fish gets killed and contaminate. Shellfish gets contaminated. Extensive dead zones often form where rivers dump nutrients into estuaries and shallow seas. Excessive nutrients support blooms of these deadly aquatic microorganisms like red tides. Now, what are the inorganic pollutants that can destroy the quality of the water. Those will be your heavy metals like mercury, tin, lead, cadmium, and heavy salts and acids. So, mercury is released from the incinerators and coal burning power points. This is the most widespread type of toxic metal contaminant in North America. Organic chemicals can also include the use of the insecticides and the pesticides that we usually use it for our to keep our crops safe. So those are organic chemicals, and the two principal sources of these toxic organic chemicals in water are improper disposal of industrial and household waste and the pesticide runoff from farm fields, forests, roadsides, golf courses, and private lawns. Sediment can also degrade the water. The silt and the sediment, they both are considered the largest source of water pollution in the United States. About three-quarters of the water pollution in the US comes from soil erosion and from the air pollutants and surface runoff from urban areas, farm fields, and feedlots. Developing countries have very serious water pollution. Despite the fall of the Iron Curtain in 1989, some of the Russian cities, along with the Balkans in Central Asia, remain extremely polluted. It's estimated that 70% of China's surface water is unsafe for human consumption, and that the water in half the country's major rivers is so contaminated that it is unsuited for any use. So this picture will tell you the situation of water. You see, all the trash, anything that you can think of, has been dumped in this water body, right? So how can this water be safe? This we don't know if it is the chemicals, the organic and the pesticides, or the insecticides, or the organic waste, or other pollutants. Everything is there in this water body, and this makes this water undrinkable, right? So these kind of challenges are very, very persistent in the developing countries, and that's why water pollution is a big problem there. Ditches serve as an open sewer in Haiti. So this is Haiti, as you can see. This is a ditch, just like a ditch, And I know we don't see these kind of things here in US, so we don't understand how can that be possible. How can there be a ditch where people are living, right? Because we are kind of in a way, we are living in a developed country and the infrastructure doesn't support these kind of things, but I have seen these kind of things and I can relate to them. You guys, there will be a ditch all of a sudden, like a pothole that develops on a road sometimes. But and you see this, there is open sewer here. Sewer is what? The sewage. So people come here and do their job, right? And this water gets contaminated. Not just with that, and children are playing right there. They don't care. I mean, children don't care, but they don't know how much polluted this water is. So that's how the condition is in many developing countries. So, about half of the people in the United States, including 95% of rural areas, depend on underground aquifers for their drinking water. So, the vital resource is threatened in many areas by overuse and pollution, and by a wide variety of industrial, agriculture, and domestic contaminants. So, the EPA estimates that 1.2 trillion gallons of contaminated water seep into the ground in the US. So when deep underground aquifers they are contaminated, um, it is possible to pump that water out of the aquifers, clean it, and then pump it back. But this whole process is very hard and is very, very expensive. You see what we are trying to say here? So, what are the various sources of groundwater pollution? These are your different sources like the septic tank systems. Septic systems would be your the sewage system, leaking septic tank. It can um, cause pollution, and then landfills, industrial waste, industrial activities, and leaking underground storage tank, injection well, okay, that goes all the way in a deep aquifer, and the recharge zone, aquifer recharge zone is right here, and this can also get polluted, and once it's polluted it will go into this aquifer region and will contaminate it. So these wells, like I was saying, these injection wells provide a direct route for injecting the pollutants, because this is a deep well. Through this, the pollutants can easily go through and will spoil the deep aquifer. Ocean pollution has very few controls. Coastal bays, estuaries, shoals, and reefs, they are often overwhelmed by pollution. Dead zones and poisonous algal blooms are increasingly widespread. We just spoke about eutrophication and we saw algal blooms over there, right? Toxic chemicals, heavy metals, oil, sediment, they all affect the productive regions of the oceans. And the other very important source of ocean pollution is the plastic. You know, guys, the plastic that we consume, we use so much, use and consume. And you know, plastic cannot get dissolved. This plastic is flowing away in all these oceans, especially you must have heard about the Pacific Ocean. And this plastic, it basically uh, uh, forms like a flotsam and jet scam. They are becoming the ubiquitous mark of human impact on the ocean. 6 million metric tons of plastic is tossed from the ships every year into the ocean. Okay, and what happens is that plastic is choking the population, mean sea, the seabirds, the mammals, and even the fish. They are choking them because they will. Fish doesn't know anything better. They will consume it. Whatever is there in the air, they'll consume it, and then plastic is found inside their bodies when they die and they are cut. You can see plastic in their inside their body. This plastic is so deadly to the marine life. You see, this is a seal, and around her neck, if you see, it's a plastic necklace. A seal, poor seal, doesn't know that this is plastic and I'm not supposed to consume it, and it may have tried to consume it, and the way it landed it, it formed a necklace around its neck. So this is a basically a deadly necklace. So marine biologists, they estimate that cast off nets, plastic beverage yolks, and other packing residue kill hundreds and thousands of these mammals and fish and other sea birds each year. The how can we treat water by remediation? Or so the cheapest and most effective way to reduce pollution is to avoid producing it. You see that? If we stop using so much plastic, if we stop you know, if we want to put it in a recyclable dumpster, you know, so this thing starts from us to control you know, the water pollution. If we don't use as much plastic, if we take care of that plastic that comes in our house, instead of just throwing it down the landfill, we can put it in the recyclable containers where they can be disposed of properly. Or we can eliminate lead from gasoline. Okay, we can some industry can reduce pollution by recycling or reclaiming the materials that otherwise would land in waste stream. So using this approach, companies can extract valuable metals and chemicals, and they can sell them instead of releasing them as toxic contaminants into the water system. So if we these this could form the cheapest and the most effective way to reduce So, first of all, we shouldn't cause that pollution. If we avoid that pollution by employing these techniques, by reducing the waste of the plastic, and then we don't even let it release in the first place, that would be the cheapest way. That's what we mean by this. Non-point sources are harder to control than point sources because we don't know where is the exact source. So in urban areas, reducing the waste that enters the storm sewers is important. The farmers have contributed to a huge share of water pollution. How? By having the fertilizers, the pesticides, and that includes sediment also. They all these things that flow from the fields, they land up in our water bodies. Nutrient pollution has degraded the Chesapeake Bay, but implementation of the pollution prevention measures and planting of seagrasses has helped this uh, challenge of managing the Chesapeake Bay. How do we treat the municipal waste, right? So whatever waste is generated by the municipal, so normally water purification occurs constantly in soils and water. The high population densities of cities produce much more waste than natural system can process. The most developed countries, they require that cities and towns build municipal water treatment systems to purify the human and the household waste. Many rural households will use septic tanks, which will allow the solids to settle in a tank, and there the bacteria can decompose them. So, municipal treatment has three levels of quality. One is the primary, secondary, and tertiary. So, these sanitation engineers, they have developed ingenious and effective municipal treatment systems. So, in the primary treatment, they physically separate the large solid from the waste stream with screens and other types of settling tanks. In the secondary treatment, they use aerobic bacteria to break down the dissolved organic compound. And in the tertiary treatment, the dissolved metals and nutrients are removed, especially the phosphatase and the nitrates. So unusual pollutants are now being detected in surface water. So this tells us that the detection frequency percent of each sample. So steroids are the largest ones that have been found in that have been detected. Their detection frequency is like 18%. And then non-prescription drugs, can you imagine? They are the next 17%. Insect repellent, 15%. Detergent metabolites, 56%. Disinfectants, 2%. Plasticizers, 17. Fire retardants, 21. Antibiotics is 4%. Insecticides is 21%. And polycyclic aromatic hydrocarbons, they are 3, and then hormones too, and other prescription drugs too. So you see how our prescription drugs, non-steroids, and other and repellents, how much um, uh, pollution are they causing? They are very important pollutants too. So alternative wastewater systems exist. So Cedar Grove Cheese Factory has built a living machine, which is a sequence of these tanks. You see all these tanks here, bacteria, algae, and small artificial wetlands. So this, it contains all these things. So it's a living machine basically. So this system, what does it do? It converts the factory effluent to nearly pure water and uh, you know wetland flowers. Remediation can involve contaminant extraction or biological treatment. What is bioremediation? When living organisms can clean the contaminated water effectively, it's an inexpensive process. So, along the stream banks or lake margins, these restored wetlands are built and they can effectively filter out the sediment and they can remove the pollutants. Some plants are very efficient in taking up the heavy metals and organic contamination. So, bioremediation has these exciting and inexpensive alternatives to conventional cleanup. Legal protections for water. Water pollution control is the most broadly popular and effective of all environmental legislation in the United States. So, these are some of the important water quality legislations that were formed in the year 1972, 1974, 1976, and you can read them on your own. Safe Drinking Water Act of 1974, like these Clean Water Act in 1985, like this. So what we mean by this is that this clean 1972 Clean Water Act, it protects our water because it was established by the NPDES, which is a National Pollution Discharge Elimination System, and it requires an easily revoked permit for any industry or municipality for dumping waste into the surface waters. The permit requires disclosure of what is being dumped and gives regulators valuable data and evidence for litigation. The Clean Water Act was ambitious, popular, and successful. This was passed in 1972. It was a bold bipartisan step that made clean water a national priority. So, this is one of the most significant and effective pieces of environmental legislation ever passed by the US Congress, along with the Endangered Species Act. The ambitious goal of the Clean Water Act was to return to all US surface waters to fishable and swimmable, because right now they are not in that condition. Only about 10% of our water pollution now comes from industrial and municipal point sources. So, so these are some of our areas of progress. And one of the biggest improvement is in the sewage treatment. Nearly everyone in urban areas is now served by a municipal sewage system, and no city discharges raw sewage into river or lake except as the overflow during the heavy rainstorms. So this ends our chapter, and these are our takeaway points that I can go over. Like water is definitely, now we have seen, is a very, very precious resource. In order for life to happen, water has to be there because water is indispensable for living organisms. As human populations grow, water is likely to become even more less and less in the future. Conflicts over water rights are becoming more common now between the countries that share the water supply. US federal, state, and local pollution controls have greatly improved our water quality in most places. In rapidly developing countries like China and India, water pollution remains a serious threat. Constructed wetlands for ecological sewage treatment provide low tech and inexpensive ways to reduce the pollution.